Okay, this is sample problem 17.7. And in this problem, what we're going to do is we're going to look at how to apply our knowledge of the KSP value, solubility product, to finding the solubility of a particular compound. So calculate the solubility of copper 2 hydroxide, CuOH2, in grams per liter. Okay? So first we have to look up the value. And so I'm going to go ahead and write it down here. I'm looking this up in table 17.4. And in table 17.4, copper hydroxide, the equation is given. 2.2 times 10 to the minus 20 is the value of KSP. And that's for this particular solubility. So copper hydroxide dissolved in water to form copper 2 and 2 hydroxides. Okay, there's our solubility. Now, let's write out the expression for KSP. Let me do that down here. KSP is equal to the concentration of the copper ion. Remember, we're not going to put any reactants in here because the only reactant is a solid. That's heterogeneous equilibria. We don't include solids in our expression for the K. Concentration of hydroxide, but there's 2 of them, so we square it, right? Copper concentration times hydroxide squared. And that product is 2.2 times 10 to the minus 20. Okay? So we look that value of K up in a table. Now, this is a solid, so again, it's not going to be in any of our calculations. Before the solid dissolves at all, the concentrations of the products are 0. Q, if they're 0, Q is less than K, which means that we're going to have an increase in these concentrations. Some of it is going to dissolve. So we go up plus S. But look here, there's a 2 there. So let me be very careful here. It's easy to make mistakes on this. This is 2S plus 2S. Okay? So use that coefficient to tell you how many are going to dissolve. 0 plus S is S. 0 plus 2S is 2S. These are equilibrium concentrations. So we can substitute them in here. The copper ion concentration is S. And the hydroxide concentration is 2S. So times 2S. But don't forget that squared. Very interesting about this. What happens is the coefficients appear twice. They appear as exponents, but they also appear as multiples based on the stoichiometry. So that would be 2.2 times 10 to the minus 20. Okay? So S times 2 squared times S squared. That would be 4 S cubed is equal to 2.2 times 10 to the minus 20. So we divide both sides by 4. And then we take the cube root. The cube root of S cubed is going to be S. So that means we have to take the cube root of the right side. Very exciting. Okay? So how are we going to get this number? Let's try it. 2.2 times 10 to the minus 20 divided by 4 cube root. Okay. 2.2 times 10 to the minus 20 divided by 4 cube root. Luckily, this calculator has it. 2.15 times 10 to the minus 7. Or, yeah, I guess I'll just use 2.15. Now that's the concentration of copper, but S is also the number of moles of the solid that dissolve into a liter of solution. So we call that the molar solubility. So S is the concentration of copper that dissolved, but once it's dissolved, once the salt has dissolved to the extent that it can. but it's also the molar solubility. It's how many moles of the solid dissolved into a liter of solution. So our next step is just to calculate the solubility, which is the mass solubility, even though they don't call it that. So what we do is we ask ourselves if 2.15 times 10 to the minus 7 moles of copper hydroxide dissolve into a liter of solution, how many grams are going to dissolve? So to do that, we need to know the molar mass of the compound. So let's erase some of this here. There we go. And the molar mass of copper hydroxide is, there's one copper. Copper weighs 63.55 grams per mole. That's the copper. And then there's two hydroxides. So a hydroxide has an oxygen and a hydrogen. Oxygen is 16.00, hydrogen is 1.01, so that's 17.01. But there's two of them, so that's 34.02. 34.02 grams per mole for two hydroxides. Okay, so it looks like it's 97.57 grams per mole for copper hydroxide. Okay, so we're going to multiply that by 1 mole of, let's do our dimensional analysis correct. We have moles per liter, we want grams per liter. So we want to put the grams at the top. So 97.57 grams of copper hydroxide per 1 mole of copper hydroxide. So moles cancel and you got grams. So we're going to take that number, 2.15 times 10 to the minus 7, and multiply it by the molar mass, 97.57. So times 97.57, and you get 2.1 times 10 to the minus 5. 2.1 times 10 to the minus 5, and this would be grams per liter, and that's called the solubility. Okay? So KSP, solubility product. S, molar solubility. There is no symbol, but if we just call it solubility, that would be S times the molar mass of the compound. Okay? And there you go.